Hello programmers! Today we're going to make a database in Python using the sqlite3 module. So we'll start out creating an empty database, and then the goal is going to be to create a table, just a container that's ready to hold information, and I thought it could be a container of bank account information. So my table name is going to be accounts, and the column names are going to be ID, name, and money, and then we can put in as many rows in this table as we want to. A table in a database is kind of like an Excel spreadsheet where you've got headings at the top and then each row has different information that goes along with that. So let's go over to Python and see what the code will look like. You can use IDLE or PyCharm or whatever IDE you want, but I'm going to use OnlineGDB, which is a website that I tell some of my students to use if they don't want to download Python on their home computers. We'll start by just importing that module so we can use all the database commands that we want, and then we're going to create an object that's going to be able to be used to create tables and insert things in tables and select from the tables. So the function connect will take as an argument to the function the name of the database that you want to create, and then you've got a variable it's actually a cursors object from sqlite3. So if I run this, then in the same location where your Python program is, it'll create a file called database.db. And if I had called it database2 or accounts or something like that, then you run it and it's going to create an empty database ready for you to put things in with that name. So I'm going to create another variable to hold my structured query language or SQL statement that I'm going to use to create the database. And I'm going to say go ahead and create a table if it doesn't already exist. The name of the table is going to be accounts. And then it's got 3 different columns: an ID number, which is an integer data type, a name, which is a text like a string, and then money, which is a floating point number. And if I go ahead and run this, so because I left the database too, we're stuck with that. So I'm going to delete my regular database. And we look, and this is a binary file. So it's not something you're meant to open in a text editor or in Excel or anything like that. It's not in necessarily a human readable format, but we can look at it in other ways. And one of the ways is by writing Python code to look at that database. So right now I've got an empty table. Let's go ahead and put something in the table. So if I wanted to put something in the table, I can create another structured query language statement saying insert into the table with this name accounts, and here are the values in the same order that it's expecting in the table. The ID number, then the name, then the money. And so if we've got that statement, we can clone this because I use the same variable name SQL and execute that. So if we run this, we won't really be able to easily see whether or not it worked. So I've got some more code here that's going to go through and select everything. The star stands for all the columns in the table. Select everything from this accounts, and in case there might be more than one row, go through in a for loop and look one at a time at each of those rows and print those out for us. So if we run this, it will insert something into the database, insert these values. And then it prints out what we have in the database. If we run it again, we might expect that there would be 2 records with Bob in, but we don't see that. So why is that? Well, whenever you insert something into the database, when you're done, you really need to commit that change. Whenever you try to insert something into the database, you've got a transaction that's been opened, but you're going to need to commit it once you're happy with this. So I've got my cursor object and then just a commit function. And so now if I run it, I've got one thing in the database. I run it again. There's 2 things in the database. I run it again. There's 3 things in the database. I hadn't really intended to have 3 clones of Bob, but let's see if we can insert something other than Bob in the database. So let's also insert a record for Kate and Sam, and when we run, now we're going to see all of that in the database. But I didn't really want this many Bob records in the database, so now instead of putting something in the database, what if I want to get rid of some records in the database? Well, then I could try something like deleting from the accounts table only the record where the name is Bob. And that actually, in this case, is going to match 4 of them for me. Let's give it a try. And yep, we've got rid of everything that wasn't Bob. So as long as you've committed, your database is going to hold all those changes that you made. So you can get rid of, like I got rid of all my insert statements. I can now get rid of the delete statement. What is it that I want to do? Let's talk a little bit more about the select command. So if you didn't want everything to be returned, you could say, well, I just want the names to be returned. And then it's going to return a tuple, even though the tuple only has one thing in it. If you wanted to just print that one thing, you could put square bracket 0. What if you want to return 2 things? You could put a comma and then say, well, maybe just the name and the money. And I want to print the tuples that are returned from there. You could say, what about returning things where the name is equal to Kate? So we just want one of those records. Now, instead of returning 2, we're going to return 1. So learning the syntax of the structured query language, it just takes some practice and learning what the syntax is. I found that it doesn't matter whether I'm doing upper or lowercase SQL commands. It seems to work either way for me. But this is a good place to stop, I think, for our first Python and database video. Happy programming!